In the vast, silent stretch of space, the Milky Way, our home galaxy, spins gracefully through the cosmos. It's a place of quiet wonder, of galaxies, stars, and dark matter working together in intricate harmony. For billions of years, this spiral galaxy has existed, a testament to the forces that shape the universe. But what most of us fail to realize is that beneath the stunning beauty of the Milky Way lies a hidden, tumultuous universe, a universe far more complex and chaotic than we can imagine. We know the galaxy's basics, the glimmering stars we see in the night sky, the shimmering dust clouds, and the occasional comet or asteroid. We have mapped out its general structure: 4 or more spiral arms, a dense star-packed center, and a delicate halo of ancient stars and mysterious dark matter that seems to stretch far beyond the reach of human imagination. But what if the galaxy, and the universe itself, is not the simple, orderly structure we've always believed it to be? What if the Milky Way, our very home, was not the peaceful, majestic body of stars we've been taught to revere, but something far more complicated, shaped by violent forces beyond our comprehension? It all begins in the galaxy's core, the heart of the Milky Way, where a supermassive black hole, Sagittarius A, resides. This black hole, weighing in at over 4 million times the mass of our Sun, is not a quiet, passive object. It has been a silent architect, shaping the galaxy's destiny for eons, but its influence doesn't stop there. As it devours gas, dust, and even entire stars, it sends out shockwaves, ripples in space-time that stretch far beyond its immediate vicinity, creating a network of invisible forces that shape everything around it. In the Milky Way's dense core, where stars and dust clouds swirl together, a delicate balance exists, one that is constantly being disrupted by unseen forces. Black holes, supernovae, and rogue stars all play their part in shaping the galaxy's core, but there are more secrets hidden within the dense star fields that we can't quite perceive. The galaxy is alive, and it is evolving in ways we cannot fully grasp. Even more surprising, however, is the discovery of a phenomenon that has puzzled astronomers for years: the mystery of the galaxy's spiral arms. For decades, scientists believed the Milky Way's spiral arms were fixed structures, solid lanes of stars that carved their way across the galaxy's disk. But recent data has shown a more complex truth. The arms of the galaxy are not rigid. They are dynamic, shifting in response to forces we are still trying to understand. The arms are not static structures, but ripples in space, patterns of higher density that move across the galaxy like traffic in a slow-moving jam. Stars drift in and out of these arms as they move through space, creating a sense of order that, in reality, is far more fluid and unpredictable. Astronomers have also uncovered something startling. The Milky Way's galaxy may not have the 4 major arms we once thought. In fact, there may be fewer, and the arms themselves may twist and turn in ways more complicated than previously expected. Some spiral arms fade away, others wrap around unexpectedly, defying all our models of a neat and ordered galaxy. The Milky Way is no longer just a simple pinwheel. It's a living, breathing structure shaped by forces we still don't fully understand. But the surprises don't stop there. As we look deeper into the galaxy, we find something even more perplexing: rogue stars. These stars aren't like the others that drift peacefully along the Milky Way's spiral arms. Instead, they are flung violently outward, ejected at hypervelocity speeds. Some of these rogue stars are remnants of binary systems disrupted by the supermassive black hole at the center of the galaxy. Their companion star falling into the black hole, while the other is hurled into the deep void of space, never to return. These hypervelocity stars travel alone, moving faster than anything we've ever seen before, escaping the grip of the Milky Way entirely, like cosmic refugees fleeing their home galaxy. One of the most shocking aspects of the Milky Way, however, is the way it is constantly growing. For all its ancient grandeur, the Milky Way is still expanding. The galaxy may feel like a stable home, but it is, in fact, a massive gravitational structure that is constantly pulling in new material. Gas from the intergalactic medium, stars from captured dwarf galaxies, and streams of dark matter feed into the galaxy's halo, adding to its mass. This slow, quiet growth is part of the Milky Way's nature. It is a cosmic entity in constant motion, evolving over time as it absorbs the remnants of smaller galaxies, creating something new with every addition. Some of the galaxies that the Milky Way has consumed have left behind traces of their existence. Stellar streams, long ribbons of stars scattered across the galaxy, remnants of smaller galaxies that once orbited the Milky Way, but were slowly torn apart by its immense gravitational pull. These stellar streams trace the paths of these lost galaxies, like ghostly echoes of worlds that were once part of something else, now forever a part of the Milky Way's complex, ever-growing structure. Yet, even as the Milky Way absorbs material, it is also the subject of absorption. The Andromeda galaxy, a giant spiral much like our own, is drifting slowly toward the Milky Way. In about 4.5 billion years, the two galaxies will collide, merging into a single larger system. While stars will rarely collide, their orbits will be thrown into chaos, and the two galaxies will warp each other, creating a spectacular cosmic dance. This collision will change the shape of both galaxies, forming something entirely new. The Milky Way, as we know it, will cease to exist, and in its place will be a new, grander galaxy, a testament to the dynamic, ever-changing nature of the universe. The Milky Way is full of surprises, many of which we are only beginning to understand. The stars that inhabit it are not static, but dynamic, moving through space in ways that reveal the galaxy's long, tumultuous history. Stars in the Milky Way follow different paths, some in neat orbits, others drifting far from the center in more erratic, unpredictable ways. Some stars are even born far from their original homes, captured by the gravity of the Milky Way and dragged into its core. These stars, with their different histories and motions, are living records of the galaxy's past, a galaxy that has constantly evolved, eaten smaller galaxies, and slowly pieced together its current form. The Milky Way, like all galaxies, is far from a perfect, stable entity. It is a living, breathing structure, constantly shaped by forces we can't yet fully comprehend. Even as we stand in awe of its beauty, we are witnessing a galaxy in constant motion, expanding, merging, and evolving with each passing day. And as we continue to look to the stars, we are reminded of one simple truth. Nothing in the universe is truly still. Even the stars are always moving. The Milky Way is not just a vast star-studded spiral drifting in the cosmic abyss. Beneath its beauty lies a much darker, more complex reality. Far from the familiar image of serene, peaceful stars twinkling in the night sky, the galaxy is a battleground, a chaotic arena where forces beyond our understanding constantly push and pull at the very fabric of space and time. Beyond the glowing, flickering stars and the scattered dust clouds, there are hidden forces that drive the galaxy's behavior. One such force is dark matter, a mysterious substance that makes up a vast majority of the galaxy's mass. While scientists have never directly observed dark matter, its effects on the movement of galaxies are undeniable. It exerts an invisible gravitational pull, shaping the galaxy in ways we can't yet fully understand. The core of the Milky Way is particularly affected by dark matter. While the dense cluster of stars in the galactic center is largely known for the supermassive black hole, Sagittarius AI, the true power behind its structure lies in the massive halo of dark matter surrounding it. This halo extends far beyond the reach of visible stars, encasing the galaxy in an unseen gravitational field. Dark matter's influence stretches so far and wide that it affects the very way the stars move, dictating the paths they take as they orbit the galactic center. In the spiral arms, stars are born and die in bursts, creating dynamic regions of creation and destruction. Yet, even these regions, vibrant with nebulae and gas clouds, are impacted by the unseen hand of dark matter. It bends the orbits of stars, pulls at the dust and gas, and ultimately guides the formation of new stars and planetary systems. The stellar nurseries, the places where new stars are born, are caught in a cosmic tug-of-war, held in place by gravity but constantly being rearranged by the relentless push of dark matter. But dark matter is not the only force shaping the galaxy. There are other, more violent forces at work. At the galactic edges, galaxies like the Milky Way interact with their neighbors, creating shocks and disturbances that ripple through space. These interactions can have a profound impact on the Milky Way, affecting everything from star formation rates to the movement of gas and dust. The Milky Way itself is a living organism, constantly influenced by external forces, and is destined to collide with other galaxies in the future. In the near future, the Milky Way will encounter the Andromeda galaxy. Both galaxies are on a collision course, a slow dance that will end in their eventual merger. While it may seem like a distant event, this cosmic collision is one of the most significant events in the galaxy's history. The sheer force of their collision will create waves of energy, forcing stars to shift their orbits, distorting the very shape of the galaxies. The black hole at the center of the Milky Way will also play a key role in this merger. As the two galaxies collide, the supermassive black holes at their centers will eventually merge, creating a single, larger black hole. This event, which won't happen for another 4.5 billion years, will fundamentally reshape the Milky Way. The once galactic spiral structure will collapse and reform into an elliptical galaxy, with new star formation happening in unexpected places. But even before that collision occurs, the Milky Way is undergoing more subtle, constant shifts that shape its very structure. One of the galaxy's most surprising features is the presence of stellar remnants, rogue stars, and black holes that drift through the intergalactic medium. These stars, born in distant stellar nurseries, have been ejected from the Milky Way by gravitational interactions with the galaxy's supermassive black hole. Hypervelocity stars are one of the most fascinating types of these rogue stars. They travel at incredible speeds, often faster than the escape velocity of the galaxy itself, and are flung into intergalactic space. As they leave the Milky Way, these stars carry with them the stories of their birth and their journey across the galaxy. They are part of a greater cosmic migration, a movement that continues even beyond the edges of the Milky Way. They are proof that the galaxy, even in its final stages of life, is still evolving, still creating and destroying, still pushing against the forces of gravity and time. The mysterious dark energy. While the forces within the Milky Way are already complicated and chaotic, they are compounded by a deeper, more mysterious force, dark energy. Unlike dark matter, which provides gravitational pull and shapes the galaxy's structure, dark energy is a force that repels, causing the universe to expand at an accelerating rate. Though dark energy is not directly visible, its effects are being felt across the galaxy and beyond, reshaping the very fabric of space-time. Astronomers believe that dark energy is responsible for the universe's expansion. As galaxies like the Milky Way move through space, they are pushed apart by this unseen force, driving the cosmos further into a state of emptiness. The galaxies, once bound together by gravity, are now being separated by dark energy. It's as if the universe itself is constantly stretching, moving further and further away from itself. The Milky Way is not immune to this cosmic force. As it spins through space, the expansion of the universe is pulling it apart, though only slightly, and not enough to impact the galaxy's survival in the short term. But in the far, far future, dark energy will become the dominant force. It will continue to stretch the universe, and over time, it will overpower gravity and all the other forces that hold galaxies together. The Milky Way, along with all the other galaxies, will eventually be pulled apart, leaving behind nothing but scattered, lonely stars drifting aimlessly in the vast emptiness. But for now, the Milky Way is not yet ready to succumb to this inevitable fate. The galaxy still has time to grow, to absorb smaller galaxies, to evolve, and to continue on its cosmic journey. The stars are still being born, the black holes still grow, and the remnants of 1,000 dead galaxies float through the galaxy's halo, telling stories of ancient times. Yet, as the stars slowly burn out and the dark energy continues to stretch space, the day will come when the galaxy's magnificent spiral structure will be no more. The Milky Way, as we know it, will cease to exist, absorbed by the vast cosmic forces beyond its control. But in its place, a new form of galaxy will emerge, and a new cycle of creation and destruction will begin again. The cycle of life and death in the Milky Way. Even in the face of cosmic destruction, the Milky Way continues to shine. Stars are born, evolve, and die, each one contributing to the overall structure of the galaxy. The cycle of life and death in the Milky Way is an ongoing process, a story that has unfolded over billions of years, and it will continue for billions more. The stars that burn bright in the galaxy today are the ancestors of the stars that will light the way for future generations. For now, the Milky Way is a living, breathing galaxy, full of mystery and wonder. It is a place of creation and destruction, a place where dark energy and dark matter battle for control. It is a place where stars are born and die, and where the forces of the universe continue to shape its destiny. As we stand beneath its stars, gazing up at the night sky, we are witnessing the unfolding of a story that is as old as time itself. The Milky Way is not just a collection of stars and planets. It is a testament to the complexity and beauty of the universe. It is a reminder that the forces that shape the universe are far beyond our comprehension, and that even in the face of its inevitable end, there is still beauty to be found in the chaos. As the engineers continued to study the mysteries of the universe, the inevitable truth began to set in. The Milky Way was not a static, eternal structure. It was a galaxy destined to change, destined to collide with the ever-expanding universe. No matter how much humans or any advanced civilization tried to control the flow of time, gravity, or space, the Milky Way was still subject to the grand forces of the cosmos that constantly pushed against it. In the span of billions of years, everything, every planet, star, galaxy, and black hole would succumb to the forces of dark energy. The Milky Way, once teeming with life and vibrant stars, would eventually fade into obscurity, lost in the cold embrace of an ever-expanding universe. But before the final collapse, the galaxy would undergo some of the most spectacular and violent changes it had ever seen. The Milky Way's last days. The universe had already begun its slow march towards entropy. Scientists had known for years that the galaxy was already on a path of collision with Andromeda. It was a meeting that had been written into the stars, a galactic collision that would forever change the structure of both galaxies. It would take another 4.5 billion years before the collision took place, but when it did, it would be an event unlike anything the universe had ever seen. The two galaxies would spiral toward each other at unimaginable speeds, their gravitational forces warping the fabric of space-time. Stars would be flung from their original orbits, but due to the vast distances between them, actual star collisions would be rare. However, the galactic cores, two massive supermassive black holes at the center of each galaxy, would eventually meet and merge, creating a new, even larger black hole at the heart of the newly formed galaxy. The merging of these black holes would release a burst of energy, a cosmic event that would send shockwaves through space. It would be a catastrophic event, but it would also mark the dawn of a new era for the Milky Way. The galaxies would no longer be the same. They would be combined into a new, singular entity. The stars and planets in both galaxies would settle into new orbits, and the once orderly structure of the Milky Way would be replaced by a massive ellipsoidal galaxy with a chaotic, disordered core. But that was not the end of the story. The universe would continue to expand, and as it did, the stars would burn out, galaxies would be pulled apart, and space would grow colder and emptier. The Milky Way, once a brilliant spiral galaxy, would slowly fade away into nothingness. The last remnants of its once thriving star systems would be lost to the darkness, scattered across the universe like fragments of a once glorious past. The fading of the stars, like all living things, have a lifespan. They are born from clouds of gas and dust, live brilliant lives fueled by nuclear fusion, and eventually die in spectacular explosions that enrich the universe with the elements that create new stars, planets, and life. The stars of the Milky Way were no exception, but as the universe continues to expand, the Milky Way's stars are gradually burning out. Some stars have already reached the end of their lives, collapsing into dense white dwarfs, neutron stars, or the terrifying remnants of black holes. These stars no longer shine as brightly, and the once vibrant galaxy that was once the center of human attention now stands as a shadow of its former self. The remaining stars in the Milky Way, those that have not yet exhausted their fuel, will eventually meet the same fate. As the galaxy continues to move toward its collision with Andromeda, the stars will burn through their fuel, leaving behind only remnants of what was once a brilliant and living collection of celestial bodies. In the farthest reaches of the galaxy, isolated from the rest, rogue stars and black holes continue to drift through the emptiness of intergalactic space. Some of these rogue stars, ejected from the Milky Way during its turbulent past, now float alone in the cosmic void, far from the gravitational pull of the galaxy. These wandering stars will burn out, eventually cooling into dark, inert objects that will never again have a place in the galaxy. The long fade into darkness. As the stars die, the black holes that remain in the heart of the galaxy will continue to devour anything that comes too close: planets, gas clouds, even other stars. The supermassive black hole at the center of the Milky Way, now alone in its reign, will continue to feed, growing larger as the galaxy's last remnants are pulled toward it. In the final stages of the galaxy's life, the very structure of the Milky Way will begin to disintegrate, with its stars and planets drawn toward the center. Dark energy, the mysterious force that drives the accelerated expansion of the universe, will continue to push galaxies apart, hastening the death of the Milky Way. The once bright spiral arms of the galaxy will no longer exist. All that will remain are the decaying remnants of its core, a small cluster of stars and black holes locked in a dance of gravity and time. As the last remnants of the Milky Way fade into the cold, endless space of the universe, they will join the growing number of forgotten galaxies scattered across the cosmic landscape like dust on the wind. The Milky Way, once home to countless stars, planets, and potential for life, will be no more. The infinite cycle. The collapse of the Milky Way is just one part of a much larger cycle, a cycle that has repeated itself throughout the history of the universe. Galaxies are born, grow, collide, and eventually die. Stars form and die in the blink of an eye, enriching the universe with the elements needed for the next generation of stars and planets. The universe itself is constantly changing, expanding, and evolving. The Milky Way may die, but in its place, something new will emerge: new stars, new galaxies, and perhaps even new life forms. The cycle of birth and death will continue, driven by the same forces that have shaped the universe since its inception. And though the end of the Milky Way is inevitable, it is not the end of the universe. As galaxies collide, stars burn out, and black holes consume everything in their path, the universe will continue to evolve, to expand, and to create. The Milky Way, like all things, will eventually fade into the darkness of space, but its legacy will live on in the stars and galaxies it once nurtured. In the end, the universe will continue its endless cycle, never truly dying, but forever changing, forever creating, and forever moving toward an unknown future. The Milky Way, like every galaxy before it, will become a distant memory, a chapter in the vast cosmic story that is yet to be written. The end